push the plastic inside my ass. It's the only way to get rid of all this trash. If the waste goes on, we're not gonna make it. Wow, wow, yippee yo, yippee yay, NatureJab's in the motherfucking house. Bow wow wow, yippee yo, yippee yay, death to plastic in the motherfucking house. Welcome back, guys. NatureJab. We've been getting a few requests about this one. Part 2 to reacting to when my boy over in Russia made that oil out of tires, and I said, his next video, he puts it in a car and runs it, potentially.
NatureJab, we need you to make sure that video is real.
NatureJab is gonna make sure that video is real. Let's do it. Let's watch it. Garage 54, my boy from Russia. I never even met him, but he is my brother. He is my biological brother. I just came out black. That's it. That's the only difference. Look, I even sound Russian. He's my biological brother. I am just the black version of Garage 54.
Hey there, fellas. We'll be trying something interesting in this video. You'd recall how we extracted a pyrolysis oil in a previous video, and yeah, on the surface it didn't look all that good. As fuel, it would only be suitable for, I don't know, a boiler plant or something.
So, if you remember in the last video, when they got the fuel out of the tires just raw as it was, fuel was pretty bad quality. It waxes up, it just doesn't look good, it's really thick and gooey and stuff. So even he said then that something else, some type of other processing needs to be done. And what I was screaming the whole video is what I learned the hard way, wasting time doing all these other things, ring around the rosy, is that you gotta distill it. So then, because if you distill it, you can crack out those waxes and stop it from waxing up, and you can also separate all the different components out so it's not as thick. But yeah, as it currently is, once it comes out right the machine, all it's good for is something that just burns oil, like a heater, just waste oil burner thing that makes heat.
Didn't want to put that stuff into a car, but we did a bit of research, looked into how we could refine it, and ultimately we ruled that chemical purification is out of the question, as we're not exactly proficient chemists. But there is one method we could try using to clean it up, that we could use to extract the lighter fractions, that are more easily combustible. Now, we used a setup similar to what you see here in order to extract the crude in the first place, and someone from our team decided to draw up a sketch of how it's supposed to look like. And on this drawing you can see a column, it's all good, but in our estimation, it seems to be geared towards a different purpose. And so what we'll do is set up a container for our synthetic crude, and the rest looks about the same as last time. We'll have the crude.
So I'm glad he said that, and let me tell you guys something. Pyrolysis is just a form of distillation. You know, when you distill alcohols like whiskey, look at a whiskey still, and look at my first reactor. They look identical because it's the same process. The only difference is what you're putting in there. It's the exact same thing. No air, piped, airtight, so everything is controlled and where the vapors go. Vaporize something inside of the container, the plastic vaporizes out, and then drips into the certain oils you want, and then you get some gas at the end that doesn't ever vaporize. Another thing to mention, he said, we're not proficient chemists, so we can't do chemical refining of this oil. First of all, distillation is a form of chemistry because you are chemically separating certain fractions. But I will also say that when it comes to actually like hard chemical refining of this oil, like trying to like put something in there, some additive to get certain things out, it's not possible because this oil is physically and chemically and atomically a blend of thousands of different hydrocarbon fractions, alright? So there's no way that you could physically separate all those out. You have to do it through distillation.
We'll have the crude in here, it comes out through here, and then through a sort of coil that will be placed inside a container filled with cold water. To me it seems as if the simpler the setup, the better the end result. And so let's go ahead and put together the device, and commence the refining of the synthetic crude. Treat it to the point where it becomes synthetic gasoline. Let's do this.
That's so much harder than it looks to coil up copper like that. You gotta put like some type of sand or water in it, completely close it shut, or else it kinks like crazy. That ain't easy to do, guys. I love this guy, bro. Like, look at him with the freaking glasses on, looking like Gru from Despicable Me. Like, I like this guy because it's not like he just is like having his guys do the work. He's out there getting dirty too, making this stuff, man. I love this guy. Garage 54, my Russian brother. Come on, man, hit me up. Let's collab, bro. Come on.
Check this out. We were able to set up a machine of modest proportions. You got a tank that used to contain a refrigerant? Like Freon, or what other names does it have? It is obviously hermetically sealed. We've welded an inlet to it. And this is the cooler itself, which is a copper tube. That goes into a similar tank meant to contain a refrigerant, which is filled with tap water that's going to keep it all nice and cool to ensure proper condensation. And the tank where the evaporation is going to be occurring is placed onto a normal sort of stovetop.
So he mentioned how this is hermetically sealed, and for those of you that don't know what that means, hermetically sealed means absolutely airtight and watertight. And so we just were talking about that. This is for just distillation, and this is absolutely airtight and watertight. So you can easily do pyrolysis in that same setup too, because guess what? Pyrolysis has to be hermetically sealed as well.
Over there we have a bit over 6 liters of liquid, which will fill the tank about halfway. And I reckon we got this. So let's...
Yeah, you never want to fill a distillation flask all the way up. When you're putting that heat under it, the stuff starts to bubble and all this. And if you fill it all the way up, you actually have that liquid bubble up into your actual condenser, and then it's going to ruin it, because then your non-distilled oils are going to mix with what comes out at the end. I've learned that the hard way too, because, hey, shout out to Shokan. And he's one guy on my Discord server, and he's helped me so much with distillation throughout the whole process. Call him Uncle Thanos. Shout out to you, man, because he taught me that right there.
So let's fill the tank, fire this up, and hopefully drain... Wait, not drain, but rather use it to extract a better flammable liquid that will work as fuel.
Great, so you can already see, just do that little bit of distillation, the coloration on the fuel is so much better. That's how it goes, because that's a separated fraction. So that murky bit that's left at the bottom is more than likely water. Because, let me believe it or not, there's actually quite a bit of water in plastics when you break them down. But look at that fuel. Look at that oil after it comes out. More than likely that's the gasoline, the petrol fraction, because it was the first, and petrol always comes first because it's like the lowest temperature.
Okay guys, it has cooled down, though the bottle has sort of imploded. We've got 1.5 liters of the so-called synthetic gasoline, is that right? It is based on synthetic crude after all. The color is good. Doesn't make you feel as apprehensive about...
You know, that's a good question and a good point. If we make gasoline from plastics, is it natural or is it not? Because it ultimately comes from crude oil, which is a fossil fuel, which is natural, so it wouldn't be synthetic, right? But then if you have something made of plastic, it's called synthetic, like synthetic fibers, right? So like, what is it? You know, is it synthetic fuel or is it natural? Let's just call it synthetics.
Now I suggest we try doing a simple comparison. This contains some regular old gasoline. This contains, 6 cubic centimeters of it. Is the stopwatch ready? Let's see how it burns. Residue, you ready? Here we go. Doesn't have enough air, so it's sort of just burning. I've poured in too much. This is gonna take a while. 2 minutes. 26 seconds. And we do see some. Obviously, there will be residue. Also, there's some grease, oil, or what is that? There isn't much left. But now let's pour a bit of that synthetic gasoline.
So that right there is an example of the prime example of improper combustion. Because people often will ask me, what are the emissions like on the plastoline? When I'm just burning it in a plate, just like here with real gasoline, it's not gonna burn well ever because it's not properly mixing with oxygen to truly destroy, and a lot of stuff is left over. But when it goes through an engine, and the engine has all those sensors which make sure it's the right leanness and all that, and then it goes through the catalytic converter, just like how gasoline is when it goes through all that, the emissions are pretty chill after all that, because there's no sulfurs in plastic.
There isn't much left. But now let's pour a bit of that synthetic gasoline. That smell is just... It's too bad the camera won't be able to pick that up.
Trust me guys, you have not smelled something so strong and pungent until you have raw pyrolysis oil just sat there like that. Like, that smell is so strong and it gets on your hands and stays for days. Going back to what I said before, they actually deodorize crude oil when they refine it into gasoline and stuff. There has to be some type of deodorization done with this fuel too, because man, that stuff stank.
Mount. Pouring it in. And here we go. That's a good burn from the looks of it. It's already all black, which wasn't the case when the gasoline was in there. That was gradually making the cup darker, but here it happened momentarily. You can literally tell.
So that's interesting that this charred up the bowl quicker than the real gasoline, and I have a theory for that actually. The reason why I think that happened is because I don't think that's pure gasoline fraction there. I think that their distillation setup was pretty crude and simple. No, nothing against them, because keep it simple, but especially with a spiral condenser like that, you're gonna have some other fractions mixed with it. The best way to have a condenser is called a reflux condenser. It's when the oils and vapors try to go up and they end up condensing and fall back down. When they have these big refining condensers in the buildings, they have these bubble plates, which are literal plates that separate the fractions. So I think that right there is probably a mix of some gasoline and just a little bit of the fraction right after gasoline, which I forget which it is. It might be some kerosene or something. And that's why it burns a little bit dirtier.
We have a fractured bowl. Looks like it isn't quite as quick to vaporize. Not as quick to burn out. I smell burnt rubber.
So it burns a whole lot longer, and once again that kind of goes back to my other theory. If there is some kerosene in there, or any other fraction after gasoline, those fractions are way more energy dense. So there's going to be more energy in there per liter or whatever. Like if you set down a burning plate and you put diesel in there versus gasoline, diesel always burns way longer. Kerosene same compared to gasoline. So like I said, if their fuel has a little bit of that in there, which would make sense why it lasted so long and also smoked up the bowl quicker.
Residue is definitely of a darker color. What we have established is that it burns well. So let's go ahead and empty the carburetor of regular gasoline, set up a supply of synthetic fuel.
I also will say that their rubber does have sulfur in it, so their fuel does have sulfur content. That's probably why theirs probably is extra stank, because they got sulfur up in there and now it's burning and forming sulfur dioxide and crap. All that nasty crap.
Right, those are oils or what have you. I can't really tell. But the residue is definitely of a darker color. What we have established is that it burns well. So let's go ahead and empty the carburetor of regular gasoline, set up a supply of synthetic fuel, and start the car if we even can. Yeah, let's see how it's able to run. Yeah, that's it. Right, so we've purged the carburetor. There's no more regular gas in there. Now let's pump in the synthetic stuff. There is a bit of sediment after it stood for a bit.
Interesting. I don't know what that sediment was there. Because if you run it through the distiller, how can there be sediment? Because sediment is solid and heavy. That should be at the bottom of the... Maybe the water bottle had some... When the water came out, the water will hold the dirt like that. And maybe they didn't pour all the water out. That's just interesting how there's just black dirt at the bottom of that water bottle. It doesn't really... I don't know what that is personally.
It works. Give it some gas. Yeah, give it a good stab.
Yes, sir.
It's revving weird. Pickup isn't too great. Well, yeah, the engine hasn't had enough time to warm up yet. But the important thing is it runs.
Beautiful work there, my brother. That is beautiful work. The engine runs off of tire gasoline. Tyroline. That is really impressive there. That is really great. And look, guys, if I had enough of my plastiline left over to put in a car, I ran my weed whacker so much with it I used it, I would have been run my car. I don't have a diesel car. And we only have enough plastic diesel left to use in a car. So, but we're gonna do the same setup. Empty out all the lines of diesel and put the plastic diesel right into the engine. Don't even put it in the gas tank because I only have half a gallon left. But let me ask you guys here on YouTube, right? Because I know we got some good scientists here, people, diesel mechanics, that type of stuff, right? On YouTube, do you guys think my plastic diesel has been sitting in a glass container completely closed for about 1.5 years now? Do you think it'll still be okay? Do you think it'll still work? Like, even if it doesn't work the best, will it still be good enough to at least run an engine and have the car drive? Because that'll be embarrassing if it would have worked, but it doesn't just because it's so old.
As for the exhaust gases, well, the smell is slightly different. It's as if it's running rich. But the cool thing is that fired up.
Yeah, I'm sure it is running rich, because like I said, their oil seems to have some other strong thing in there, and that's going to throw off the stoichiometric ratio in their engine, because just burning the normal gasoline is not enough, because then there's this other energy dense thing in there, maybe kerosene, that's left over, so it's going to be definitely rich.
It starts and runs perfectly fine. Okay, let's pack up and head to the test track. 0 to 100 on 92 octane. Resetting the device. And let's see what it can do. Bit of wheel spin. And though this is an older Lada, right, so it's 5.9 to 60 Ks, 16.7 to 100. Okay, let's run it on the synthetic gasoline. Holy cow! For real? I can't see the results yet. So 0 to 60 kilometers an hour was 5.6. 0 to 100, 16.5 seconds. So it's even a bit quicker by a few tenths of a second.
The engine also sounded like stronger too, but once again, I really think it's because there's another fraction in there, a really more energy dense fraction that's in there that's causing it to rev up higher.
But we'd better go again. First time is never right. Here we go. So the 0 to 60 time is a consistent 5.9, 5.8 seconds. So we have poured in a liter of conventional pump gas. Now I start the car and drive. Here we go. And we've stalled. Now we stop. Right, guys, we've traveled 8,300 meters, which about corresponds with city fuel consumption numbers. Distance driven on synthetic gasoline. And we're off. I have brought the revs up and let's go. And we're done.
Wow, just shy of 9,000 meters. So that's a few hundred more than the real gasoline. Once again, I think it says there's another fraction, another energy dense fraction in there, but I could be wrong, and it could literally just be more energy dense. There's some research papers that talk about that actually, that the plastic pyrolysis fuel actually burns longer and is stronger, has more energy and lasts longer than regular. So it's a possibility. That's just crazy, and I love that they did that test. So guys, that's pretty much the video there. Some really good scientific data, but I want to make sure that it's irrefutable that, you know, we're doing the same thing, and I think as long as I put it directly into the engine, half a gallon will be more than enough, because what, they just put like 3 liters of the stuff in there, and half a gallon is like, I think it is, you know, just a little bit over 2 liters. That's so exciting to see. I love that guy so much, and I got nothing but brotherly love for him, man. You know what I'm saying? Like, that's real talk, like the Island Boys type brotherly love. You know what I'm saying?
What did he say?
Well, anyways, guys, thank you so much for watching. We're gonna be doing this very soon, very, very soon. As soon as I get my hands on an old diesel, we're gonna gosh dang do it, and I'm so excited. NatureJab out.